Okay, hello and welcome back to my Project Euler series in Python. So this is problem 4, largest palindrome product. A palindromic number reads the same both ways. The largest palindrome made from the product of two two-digit numbers is 9009, and that's 91 times 99. Find the largest palindrome made from the product of two three-digit numbers. Okay, so we need the product of two three-digit numbers. We need the largest of them that is also a palindrome. Okay, so let's start by making some three-digit products. So for I in range 999, if we start high, because we want the largest, right? So if we start with 999, let's go down to 99. And to go down, we need a step of -1. And then if we duplicate that line, do the same thing for j. And then if we just print the product of I times j, that should be what we need. Okay, so that's printing the products. So now what do we want? We want to see if it's a palindrome. Okay. So palindrome is the same thing forwards and backwards. So if let's put this in a variable. So if product is equal to I times j, and if product is equal to, so I want basically the reverse of product. Okay, so if we can convert product to a string, and then there's some kind of like list slicing, but a string can be treated as a list of characters. So if we do some kind of slicing on it, where we don't set a beginning or an end, but we just set like a step of -1, then I think it's going to read the string in reverse. So hopefully that's the case, and this should basically be the string version of product, but with the digits in opposite order. So I can convert this back to an int, because hopefully if that's worked, it should still only contain numbers. And if that's the case, then we can print product. And so now, this in the terminal, while it before was printing all of the products, should now only be printing the palindromic products. Yeah, there you can see they're pretty much all palindromes. But there's a lot, and we only want the largest one. So, and oh yeah, so if we only want the largest one, then, and we're counting down each time, we're starting very high. So if we can find something early on, we're not going to need to do the rest of them. So we're not going to need to count down. So for example, if I is 999 and j is some other number that creates a palindrome, then we don't need to keep going down. Once we found that palindrome for that j value, we don't need to keep reducing j, because it's only ever going to produce a lower palindromic product. So we can just break after this. I think if we can break out of this, then it should only produce one palindrome product for each I value. Still be I think 899, but yeah, you can see that's a lot less. Should be 899 if there's a palindrome existing for every I value. Okay, so now we want the max of these. So let's add them to a list. So palindromes equals empty list, and then we can say palindromes dot append product, and then we can print the max of palindromes. Yes, I mean, it's not thrilling me with efficiency, but it does the job. So yeah, you can see there's a slight pause. I don't know if that's just me, but it feels like, we're calculating more than we need to, because we don't need to keep going down in I to create these products. If the products are already lower than the maximum palindrome we already have, because like I said before, we're only decreasing our j value as we go, we're only decreasing the I value as we go. So once we've made a product, if it's already going to be lower than the largest palindrome we have, then it's not going to overwrite it, it's not going to set any records. So we might as well say, if the product is less than the max of palindromes, then break, because we don't care. We don't care what the rest of the j values will be, because they can't beat the max we already have already. Okay. Max is an empty sequence. Oh yeah, because on the first run through, if we haven't added anything, then can't have the max of nothing, so let's just set it to 0. Okay, wow, that was nice. That was nice and fast. So I actually think we're going to be adding them in ascending order. I think it's a similar thing to problem 3, where we're adding our prime factors in ascending order. So in problem 4, with these restraints of adding the palindrome, it has to already beat what we've already got in palindromes to make it this far. So we're going to be adding them in ascending order, which basically means we can do this and just take the last thing, because the max will be the last thing if they're being added in ascending order, which means we can also just print the last thing, and it saves the max function a little bit of work. Nice. Okay, so that is our answer. Haven't verified if that's actually correct yet, but I'm pretty confident, because it's come up pretty much every time we try to run anything. So I'm pretty confident that it's a really large palindrome, and it's probably the one we're looking for. Disclaimer, I have done this problem before, I've done a lot of them, so yeah, and as expected, that is the answer. So yeah, problem 4 done. Hopefully that was a nicer lesson in how to start with the basic principles of just creating the product of 3-digit numbers, and then figuring out if it's a palindrome or not, and then slowly lowering the search space by ruling out options that can't exist. And that basically got us to the answer and exhausted all other possible answers a lot quicker, and now the program runs really fast. So yeah, I hope you enjoyed that, and I will see you on the next one.